Okay, so this will be questions 1 through 5. Tell whether the function shown by the table is linear or nonlinear. So what we want to check is the difference. So I'm going to pick any point in the table, subtract the point that comes before it to find out that difference. So the difference is 2.5. So if I take 9.5 and add 2.5, I should get the next point, which I do. That's 12. So I can see that it is adding 2.5 to every term. So this is a linear function. What appears to be the relationship between x and y in the graph, which we don't have a graph here, we just have a table. We can see that the rate of change is constant, and it is 25. And the rate of change for x is 1. So I know that my rate of change is delta y over delta x. And so my rate of change is 25 over 1. I know I need to find the y-intercept. So I know that my rate of change is 25. And y equals that rate of change. And y equals 25x. And I can see in most of these the y-intercept is 0, but I do need to double check. So we're going to plug in a point. We're going to plug in 1 for x. And we're going to find out and see if we get 25 for y. So 25 times 1 is 25 for y. So there's nothing I need to add or subtract on the end of my equation to make this work. So I know that B is the solution. Bill earns $24 per hour using P for pay and H for hour he works. Write a function rule that represents the situation. Well, let's make a table. So let's start with H for hour, P for pay. Works 0 hours, he makes $0. If he works 1 hour, he makes $24. 2 hours, I will add 24 to that, and I get 48. 3 hours, I will add 24 to that, and I get 72. So I can see that my change in y over my change in x is 24 over 1. So my rate of change is 24. My y-intercept is 0 because when x is 0, h is also my x. X is 0, y is 0. So P, my pay, is equal to 24 times my hour. Okay, find the 4th, 7th, and 10th term in the sequence described by this rule. This is the explicit formula. So I want to find n equals 4, I want to find n equals 7, and I want to find n equals 10. So I should get 3 answers. So to find the 4th term in the sequence, I'm going to plug in 4 for n. So I get 4 minus 1 equals a of 4. 4 minus 1 is 3. So a of 4 equals 7 plus 3 times 3. 3 times 3 is 9. And 9 plus 7 is 16. So the 4th term in the sequence is 16. Now I want to find the 7th term. I'm going to plug 7 in for n. So a of 7 equals 7 plus 7 minus 1 times 3. 7 minus 1 is 6. So a of 7 equals 7 plus 6 times 3. 6 times 3 is 18. 7 plus 18. 7 plus 18 is 25. So the 7th term is 25. Now I want to find the 10th term. So we're going to plug 10 in for n. Okay, 10 minus 1 is 9. So the value of the 10th term is now equal to 7 plus 9 times 3. 9 times 3 is 27. I get 7 plus 27. So the value of the 10th term in the sequence is 34. Okay, an arithmetic sequence is represented by this explicit formula. Write the recursive formula. Well, let's write down the formula first before we do that. So in the formula, this is the recursive formula. A of 1 equals the starting number. Next part, A of n equals A of n minus 1 plus the common difference. So I want to fill in these two parts, common difference and the starting number. Well, the starting number in this formula is right here. That is A of 1, and this is the common difference. So I'm going to fill those parts in. So A of 1 equals 3, comma, A of n, the current term, equals the term before it, minus 4, my common difference. This is my answer. Okay, you can go to the next video for the next problems.